7. It breaks my German heart. It's 2 minutes late. Yeah. Oh, but welcome from my side as well. I'm happy to see so many familiar faces and some new faces as well. My name is Markus Frank. I work in IT, and I'm doing the facilitation for the morning. So, as every year, I would like to see who is here, and that we do by go through kind of the different sites. And then you can stand up just, and then we can have a look. I'm not sure if you can see who is standing up and not, but I can't at the moment, but maybe I move a bit. But we can start maybe with Kevitsa. Can you please stand up? Oh, welcome. I can get an applause as well. Very good. Let's move on to Aitik. It's also an applause. Very good. Thank you, Boliden area. Thank you. Boliden office. Oh, very good. We move on to Garpenberg. That's good. Wonderful. Tara, do you have anyone here from Tara? A few people? Yeah. Wonderful. Stockholm, head office. Perfect. And I see Jani is also standing up. I was about to ask for smelter site and head office. Perfect. And then we have also a lot of external guests, I guess. Can you also please stand up? Or non-Boliden. Very good. I think it's the first time everyone got an applause for standing up, which I think is great. Good start. Well, I clicked one time too much. Sorry for that. Oh, thank you. So this is the agenda for today. I think also this year we have inspiring presentations, and I'm not so sure if everyone has seen the agenda at all, but it's here now. And we also have it outside when you enter the conference room. We have breaks, of course, and we have one session now, and then we go for coffee break. The sessions are 20 minutes. You can ask questions afterwards, and we hope for a lot of interactions, of course. Very good. But then we maybe move to the first session, and super happy to have the IT colleagues here and also Viktor Frank from Garpenberg Mill to talk a bit more about implementations. And now I'm a bit mean to Rasmus. Where is he? Over there, yeah. When we talk about moving things into production or something is ready for production, then there's a difference between production and ready or used in production. So the time between having something tested and prototyped to actually implemented it and getting value out of it in the operation can be quite long. And that is quite natural as well, and that's perfectly fine. But here we have now examples, 2 interesting projects that the team is taking away, and that's Fredrik, Martin, Jocke, Anton, and Viktor Frank. Welcome on stage.
Okay, welcome to this session. My name is Fredrik Hases, work within the digitalization hub within Mines IT. Today we will present 2 kind of smaller sessions where we talk about implementations, as Markus said. The first thing, and the session is also called TECHwalk. I think that this is kind of important. Why is it called TECHwalk? Yeah, because we talk a lot about technologies, we talk a lot about research and development, but we also need to do the walk. We need to implement it. We need to make it to the production. We need to be able to create value out of it. And that's what we're going to do now. We're going to walk you through. We're going to talk how do we implement this and what are the challenges into that. So there will be 2 sessions. One of the first session will be about the, as the last project Rasmus presented, the object detection, as we now call it, for the conveyor belts in Garpenberg. And the second one will be about the tailings and environmental platform that we use to monitor our environmental performance and keeping control of our tailings facilities. So there will be two interesting projects or implementations to present. So first of all, I would like to welcome Viktor Frank from Garpenberg. He's a process operator. Joachim Jansson, data scientist from the Digitalization Hub, and also Anton Nyman from the data and analytics team. So please welcome on stage.
Hello, hello. Can you hear me? Yeah. So first, I would like to thank Marcus Frank for designing the presentation that we have. So shout out to you. And also, we're here today to talk about all the use details about hyperparameter tuning and why it's so important. No, actually, we are not. That was more an attempt of a joke to all of the nerds out there in the crowd. But for the rest of you, you're probably wondering, what is this guy blabbering about? No, actually, we're here to talk about the importance of having iterative collaboration between machine learning developers and end users to give actual business value. Iterative collaboration between end users and developers to really understand the end user needs is what we believe the key component for success, not only for machine learning implementations, but for the the majority of IT implementations in industrial settings. And to illustrate this, we're going to talk about, boulder detection that Rasmus mentioned, a Garpenberg developed machine learning system that detects unwanted objects on a conveyor belt. And when we got started on this project, we got the specifics that we should detect and position 2 large boulders on a conveyor belt. That seems kind of straightforward, right? I mean, if you look at these are really big boulders, should be easy to detect. So let's listen to Viktor, an operator at Garpenberg Mill, that will explain what kind of boulders they want to detect and why.
Thank you, Anton. Hi, my name is Viktor Frank, and I've worked for Boliden Garpenberg as an operator for almost 10 years now. I was invited to this project to help Joachim and Anton to understand me and my co-workers' reality in our work field and what we want to get out of this. In the mines, we have so-called stone crushers that crush the boulders before it comes up to our conveyor belts. And sometimes big boulders, they just slip through, like you see in the picture. This stone, for example, had gone far in the process and in some incredible way ended up crooked and stuck, as you can see. This not only caused a stop for us on the conveyor belt, but it managed to push the belt in as well and made the task take longer than usual. But the funny thing is about this picture, you see the sledgehammer? I haven't used it yet. The stone set so tight in tension that it split itself, so it felt a little sorry for me and helped with something. Most of the times, the stone's not so kind to you. Here you see the last stop for a stone's journey before it is to be crushed in our primary mill. And this did not want that. It got stuck on the side and caused a big stop. This is a real time-consuming process to get rid of. First, we had to stop the whole grinding process, look out and tag out several objects before we can even pull out the mill feed chute. Then comes the next problem, where we have to remove all the stones again. We either toss it manually into the mill again or in a bin. This takes time, which costs both money and muscle soreness.
Yeah, so after we got the specifics from Viktor and the company, we got started on the model development. We launched the model into a production environment and started to monitor its performance. Quite soon we realized, well, it's kind of difficult to measure the performance of this model, since, I mean, what is a too big of a boulder? And also, when we were monitoring this model, we noticed some interesting objects on the conveyor belt. And we thought that these could be easier to measure performance against, since they're easier to determine if they shouldn't be there or not. So we took these findings and went back to Viktor and the company and asked if they were of any interests.
Well, yeah, there are many unwanted objects that come along our conveyor belt. For example, we have rock bolts and wires that come regularly. And we have some objects that comes more seldom, like ventilation tarp. But we don't only get boring things. Sometimes you can get a good laugh out of it as well. We received, as in the picture you see, a fence. They were really glad we had to stop early, because this one wouldn't be fun if I continued in the process. We have gotten other objects as well, like tractor tires, electrical cabinets, and so on.
So, with this new information, we went back and created other models to monitor these other objects as well. And we got some really interesting findings. We detected a lot more objects along our conveyor belts than site initially thought was present. And the equipment on site currently gave a false image about the amount of objects, or for that matter, didn't detect some objects at all. So, but detecting this many objects raised some interesting questions. This is a lot of objects. Well, first of all, should we remove all of them? And the next object, well, there's a lot of objects. Do we even have time to remove them from the conveyor belt? But let's take the first question. Well, should all of these objects actually be removed, Viktor?
No. As an example, initial garbage contains several different objects. One of these objects in particular, tarp, causes severe issues in the process. It, for example, gets twisted in our rollers on the conveyor belt. This is an object that, by communication between the developers and domain experts, was decided the tarp should be its own group that we should detect and stop for. In this way, we collaborated to understand what objects should be detected and act upon.
So, okay, that's interesting, but then the next question is, well, there's still a lot of objects. So, in general, how long does it take to remove an object? Let's say that the laser camera that's there today stops the conveyor belt, or that you as an operator manually stop the conveyor belt. How long would it take to remove an object from the conveyor belt?
Yeah, that depends, okay. If you ask me now, or if you ask me 5 years ago. In the present time, we have 2 lines of conveyor belts that transport the ore from the ore elevator to our ore storage, which we divide into the old one and the new line. There are a huge difference between these two. With the old one, we can say that we work more analog, where you must be on site to solve the problem and do a lot of manual work. We smash the stones by hand to suitable size to ensure it would not get stuck in the next step, and if the stone was too big or too hard, that it made it basically impossible to smash it with a sledgehammer. We had to lift the stone up with a strap and a crane. This was very risky, as we lifted the stone from the belt and down to floor level, where the stone could slip if you did not secure it properly. So it was really important to cut down off before beginning this work. It was a very time-consuming, stressful, and costly process for us operators who have the task of getting the process to go as smoothly as possible. Here you see one or two times our so-called boulder flag we used to have stopped for a boulder. But for most of the times it was stopped for bolts, but it was not its initial purpose. And here you see one of the common things for the old line. A boulder that's too large to get out of the feeder and get stuck, which we needed to manually remove it. The old line, it got a proper upgrade where we installed a so-called hydraulic boulder hatch. That meant that we did not have to sledge a stone on the same large scales anymore. The boulder hatch, it works by maneuvering it from a panel. Then you press the button that makes the belt go slowly through the edge with the boulder. You press another button so the hatch goes down. And you press so the conveyor belt goes to the hatch and driving the stone down, which then goes through a chute and down into a stone bin. But sometimes the boulder still wins, even though we found an easy way to remove it from a belt. It's a living. Then, as a sum from above, we acquired a new line where we, as I call it, you work more digitally. We upgraded it with large belts, a laser that measures if it's a large boulder or a bolt coming from the feeder. The boulder hatch, of course, and hydraulic shelf in the conveyor chute, they can be retracted if there would be a stop there, as you can see on the picture to the right. You pull in the hydraulic shelf, the object goes down to another belt, and then we can decide if the object is too large, or we can let it go further in the process. We have developed these steps to be able to run via our control system, which means that you do not need to be inside as much anymore, but instead maneuver it from the control room. This saves a lot of downtime for the ore elevator and the stress for us operators to get production up and running again and be able to perform the different other tasks we have as operators. With the new line, we have not only shortened downtimes, we reduced pinch injuries for us operators as we handle bolts in a complete different way now, and the belt damage has been significantly less. But despite all these measures, we still have challenges, so we think it is important to continue working on this to reduce the downtime and injury risks. And here's where the object detection system comes in. We want to stop and handle all problematic objects early in the process, where they can be safely and easily handled and removed.
Yes, so we were a bit lucky there in the project that they actually placed control for the boulder hatch inside the control room, because suddenly removing an object would take only 60 seconds. And then actually you could actually remove 60 objects in a shift. Then it's more of a question of, well, how do you prioritize what objects to remove and during which circumstances, as Viktor mentioned earlier. Another interesting thing about these kind of models is how you measure performance. Normally you would just take the amount of true positives and false positives, true negatives and false negatives, plug and play into some equations, and well, then you got the performance. But actually in this kind of problem, it's really hard / impossible to know the amount of false negatives running around along the conveyor belts. And also, it's also problematic that not all bolts are created equal. If you look at our model's performance on large bolts, it's actually really good. But if you look at small and hidden bolts, the performance is actually a bit worse, and this is totally natural. But it really depends then, well, what is more important? Are all bolts equally important, or are the large bolts important? If the large bolts are the only thing that's important, well, then the small and hidden bolts skew the performance in an unfair way. But also the other way around. If large bolts are not important, the only thing that's important is the small bolts, well, then excuse it the other way around. It's really easy to have some kind of arbitrary performance demand on a model, but that does not necessarily give value to the business or actually make it work as intended. Rather than focusing on performance demand, we would say that sit down with operators, talk to them, understand their problem, see what they are actually trying to solve, and see how that can bring business value, and focus on that instead of some kind of arbitrary performance demand that, to be honest, can be mixed with pretty easily if you have a semi-competent person working on the problem. No. Vad du vill ha?
Yeah. So we could have built our model based on the first requirements that we got in the beginning, without ever being on site, without ever looking at the process or have any discussions with the operators. And we could have stayed behind our desks, trained or developed our model based on some stored data that we got, and then do that until we got the performance that we wanted. But that system would have produced very low, if any, value to the organization or to the company. And it would probably not have been used by any operator. But we could have said, like, we have done nothing wrong. We just follow the requirements, right? But what is more important, though, is it that we blame someone else that we did not get the correct requirements at the beginning, or that we, together with site personnel, try to find the correct requirements so that we gain actual business value? And from a demand perspective, it's kind of impossible to foresee all of the mentioned insights here now. Instead, we believe that fast iteration and collaboration between departments is the key component for success to gain actual business value, not fine-tuning a hyperparameter so that we increase the performance or accuracy a few percentages.
What you must understand is that this is the reality that the business works with. It is difficult and complicated. Here, in this picture, you see a work that it took almost 10 hours for us to clean up. And this reality does not only apply to us operators, but also to the machine learning and IT systems that are going to be deployed into this environment. When you create a project, communication is everything. It is important to communicate with everyone who has something to do with the project. Then it becomes a good end goal. Those who do not work in the process must listen to what the end users have for wishes and needs for what is to be implemented. This is important to help them in tough working day that they work in and not ruin it for them. They are more likely to use the system then. Thank you.
Thank you.
Thank you very much.
Thank you.
There will be opportunities for questions and answer after this. But now we will take you to the next presentation from Martin Lilja. Please, Martin, come up onto the stage. And I think that we forgot the clicker. Yeah, Anton had it. You shouldn't steal things, you know. Here you go.
Thank you.
So, Martin.
Yes.
You have, for the last year, been working on a very, very interesting and important project for monitoring and implementing this advanced tailings and environmental monitoring platform that we have. Can you please walk us through what have you done for the last year?
Okay, thank you, Fredrik. It's basically two different organizations or departments receiving this platform. One of them is the tailings storage facility, which that facility stores our waste material from the mill. So everything we can't use is being waste. We need to store that someplace. And that's a mixture of sand and water, and it has elements of not very good materials for the environment, like arsenic and lead, so it needs to be stored in a very safe fashion. It's very advanced instrumentation measuring those ponds or dams. I mean, if you think of the size of this, the Aitik Dam is pretty much the size of the city of Stockholm, and it's 100 meters deep, and it contains a lot of slurry that we will not want to discharge anywhere.
Okay, but we did have a platform before, right? So why did we build a new platform?
Yeah, we didn't have a platform before. It's very scattered around. Some sites are using proprietary products, so they have bought in platforms that doesn't really do the whole job. They might measure some things, and for others they need to go and do manual readings. We might need to integrate with third-party vendors. So there hasn't been a global Boliden platform for this that we can reuse.
Why is this so important then? Why is it important to have this kind of platform?
Well, if we look at the environmental department, who will also receive their platform, I mean, they do the work of the environmental monitoring on a pretty large area around our sites. They measure for contaminations in water, in groundwater, and through our license to operate, we need to be within certain ranges in order to keep that license. So it's very, very important that we have a lot of this information easily available for the business side, and it hasn't been easily available.
Okay.
It has been taking a long time to just conduct a weekly or a monthly report. It can take weeks just to gather all the information needed for this.
Okay, but when we look at these kind of platforms also, I think that, I mean, if we are on top of the game when it comes to this, I mean, for us in Boliden, it must be good also if we have this kind of vision that we should be the most climate-friendly metals provider in the world and so on, I guess. So I think, you mean, when you've been working on this platform, you have also thought about being best, I guess.
Yes, of course. And I mean, if we can do a template and roll this out, because it's no difference how they work with environmental data in Garpenberg or Aitik or Kevitsa. They do, however, have different ways of work. So we have a big job and a big gap analysis on just identifying how each site has been working on gathering this information. Some has been a bit automated. Some are very automated. But there hasn't been one kind of data platform to gather all of this information.
Okay. How did they do this before then? When I mean, we have done this. Of course, there's been legislations forever, so not forever, of course, but how did they do it before?
Yes, so this is a manual instrument to measure water levels in a manhole or in a borehole, because you usually want to find out what is the water depth. And around the site, as I said, just imagine the size of this. You have to drive around, you have to pack your car with a lot of gear, you have to go to each of those measurement points. So this is actually a tape measure. Let's say it's 20 meters long, it has a probe in the end, you put it down, and it will beep when it hits the water. So take the reading, you know that it's 15 meters deep now. And you do this for all your points. That will take some time for you to do. And when you've done that, I think they sent me a really good paper, because when I was at site, it didn't look like that because it was rainy and we had dirty hands. So it didn't look like that. So that's usually what we do, or what they do. They write their figures, they go back to the office, they put it into Excel. The big production system, which everyone loves.
Very reliable production system also,
Yeah.
Excel. Yeah.
Yeah, so I actually got that file sent to me, and I tried to open it twice, and my computer just crashed. So I called the guy back and said, "There's something wrong with your file. You need to fix this." And he said, "No, I'm working with it right now. How long are you waiting?" Well, 30, 40 seconds. I work with IT. Oh, you need to wait for 3 or 4 minutes. I think it was 5 gigabytes, and it had 20 years of data in it. So that's what we started working with.
It works, but it might
Yes.
not be the best way to handle this kind of data, actually.
Yeah.
It's scary. It's scary to listen to this, actually. Yeah.
And I mean, if you see my colleague here, Ludwig, we were at site and we were going out to get some samples. I couldn't carry that. I'm not that strong because it's 2 car batteries and the truck was loaded with a lot of gear, with pumps and everything. And you had to walk through this muddy field twice because you couldn't carry everything. And I couldn't carry anything, so I was just walking without carrying. So it took us, usually it takes 2 to 3 hours just to pump up the water from one station. When you're there and you see this, it's like, okay, this is no problem to fix. We put a cabin, we put the batteries in, we put a solar panel, we put a pump, and then they can control that through sending a message to the pump 2 hours before they go to an IoT device who just activates the pump, starts pumping.
This is interesting because you have been out with the business, looking on how they do it on various sites, of course, kind of living with the business, never being in the office, which is good because office space is also expensive. So that's why it's good that they are out on the business. But anyway, so you've been out there, you've been seeing this, but you also have some kind of background. You really know a lot about technologies that can be used for this. So what kind of technologies have we been used now? What have you been seeing that we can help them with?
Yes, so each site and each department have also different possibilities. I mean, if we look at a site like Tara, they have really poor LTE or 5G connection out where we are collecting information. So there we had to rethink. We couldn't use devices with SIM cards. So we had to design a LoRaWAN, that's a long-range radio network where you can send information over time. So there we designed a LoRaWAN network, and it works very well. So you see the tech stack here. The kind of idea we had was that we shouldn't buy any new technology for this software. So we didn't buy anything new. We utilized what we had, and that was the idea to be very cost efficient rolling out this project as well. We have standardized all our IoT data communications on the MQTT with SparkPlug-B, so that's a standard, more of a standardized way of sending data over that protocol.
Is it open?
Yes, it's open. It is open, and that's what we have been striving for. We have replaced a lot of the proprietary products that, I mean, if you're on the business side and you don't get help from anyone that has this knowledge, and a provider comes to you and they say, well, here's a super good solution for you. You get this dashboard, you get our sensors, you get everything. But then the problem comes when you want the raw data together with other information, maybe from your DCS system or to calculate this.
And what will happen when such a company will cease to exist?
Yes, exactly. So we do a lot of R&D projects as well on the MQTT standard with providers now. So for example, the providers that provides our piezometers, they only send the data on an FTP today. But we have got them to start developing an MQTT LTE gateway for us. So we are going there.
What I understand, so that we have this kind of first a data platform, and then you can use whatever visualization tool you want.
Yes. So that's the nice thing about this. When you standardize on the data consumption layer, we use Aveva Pi for this. So we've built up pretty much the site, the tailings, and the environmental department, and all of their data, how they structure it. And then it's just a matter of how they want to see it. So for Kivitsa, we are visualizing it in a completely different way than we're using for Garpenberg, for example, because they have different needs. You can use Power BI. You'd like to use Excel. You do that as well. Anything. Grafana, PyVision. So anything, and it's very focused on the business needs. I work very close to the business and try to understand what they need to see. But there's also dangers, too much information. We see that as well, because when you connect a lot of things, you get so much information, and it's so detailed. So the question is, what's important? What do we need to scale? Do we need to compress?
That's another question, because are we done yet? Could we say that we are done with this platform? It's rolled out, we are creating value, and now we're just laid back, or?
Yeah, we're laid back now. No, that's the good part with this. It's in constant change, and we are working on replacing technologies at site, because you can't do this. I'm running 6 projects in parallel right now. Total, there will be 8 rollouts, and we are changing everything from how the organizations are working, systems they're working with. So we need to take it in blocks. And I think a good thing that we did for this project was that we were focusing on a kind of basic need foundation, because we are implementing now a basic foundation, but where they came from, it's basically 10, 20 times better than what they had. And we've just started.
What would you say are the challenges now?
Yeah, I mean, Excel, always a challenge, just identifying all the information in those. But the challenge is to have someone to actually govern the full solution, and helping the sites with this, because we have now provided the sites with a full stack, almost helping them to choose how to communicate with their instrumentation and how they visualize it. And we need to have an organization who can actually drive this support and governance.
Like a product team.
Like a product team, and really take away the tech from the sites, and help them with that, because we need to step in there. We can't. I don't think we can think that we just leave this there and then we go and do the next thing. We need to support them continuously if we want to have a living platform.
Yeah. Do you think that this is the way how we should deliver value then also in the future, that we should be so close and not maybe just give them a service and here consume it, or more being with them?
Yeah, I mean, we always talk within IT what it means to work close with the business. That's something we've talked about since I started 6 years ago. But I don't think I work close to the business. I work at the business. I'm a colleague with them. I go to the site. I go out trying to carry their batteries. I try to understand what the problems they have. I mean, last month I was visiting 3 sites. So I think it's very important to be super close to what you are doing, and also have an interest in it. Try to understand. I mean, they are super competent in what they do.
Yeah.
I can't understand the figures and the graphs they're looking at, but I can understand the problems they have when they don't have the graphs, or when a report takes them 3 months or 2 months to just get all the information for that.
That's cool. Of course, we have, like, if someone wants to see the platform, we don't have really time for that right now. I'm sorry for that, but that's kind of okay. I mean, please ask Martin if you want to see it. He can show it to you what it's capable of, so on, what we have done. If you want to know anything more,
It's a big Excel. I will show you.
Yeah, it's a huge Excel. Yeah. So I think that we could open up for some Q&As. I know, Marcus, you have some questions actually that you have prepared in case no one will ask any questions.
Exactly. True. But I think we can ask the rest of the speakers to come on stage as well. Thank you. Oh, I don't need. Actually, I just want to ask Fredrik one additional thing, and that is, you guys talk a lot about success, making implementation a success, and if you want to add something there from your side as well.
Yeah. First of all, to be interested in the business value chains, I think that is the most important. To be interested in the processes, what are going on at the business, that is to be close to the business. And I think that is one of the key success factors. And also one thing, I think that Rasmus also mentioned it, we really need to celebrate the people that work with our infrastructure, because we at Boliden are tremendously good at networks and server infrastructures, and they don't really get the appreciation they need, actually. So we are superb at that. That's one success factor. But otherwise, and because they who work with this, they really are interested in the value chains and the processes also, so they know what they are doing. That is a key success factor.
Thank you. We have time for questions, and we have this new thing that we didn't have last year, and that's a microphone, and it's robust, so we can throw it around. I will not throw it at you, because everybody will just move away. But if you have a question, you have to hold it close to your chest, and then it works. So the question is, are there questions? Yeah, there's one.
Thanks. Now it works. Yeah, the boulder detection. I understand you have put it in the mill now. Have you looked to move it even further upstream in the process?
Testing.
Den var.
Den var på. Eller? Tack. Hallå. Ja, nu så. Jo, nej men det finns ju många... sorry. Well, yes. So there's a lot of places where you can put it, and where it could be a good idea, and there's been discussions on that, and I would guess that we will probably get there, but firstly we are still implementing to making sure that it can actually stop the conveyor belt so the model can stop the conveyor belt by itself, in the same manner that the laser camera does today. And with that, we will try to evaluate how the business feels about it. But from a discussion point of further on, yes, there are discussions about having it in multiple places. For example, if you would put it on the conveyor belt before the skipper, it's really interesting to actually remove tarp in that position, because tarp can really cause a big problem in the skipper if it gets hooked up in the wrong way. But still, then you have to analyze what you should do in a specific place with a specific object. So yeah.
Good. Any more questions? There's one up there. Oh, that's going to be challenging. I think I will go around.
You could throw it also.
Oh, I'm not sure. Should we try it there? I will throw it as far as I can.
And just pass it along.
Perfect.
I caught it with my face. So, good throw. Martin, about the environmental measurements that you're doing, we worked with it a bit at Tara, so I have a good idea of what you're going to say, but how are you managing with dealing with the business getting what they want from the supplier, but us not getting what we want from the supplier, in terms of our business contacts are happy to receive these reports on a PDF or on an Excel file, and they're happy to keep an Excel document on their desktop, but we want to get it into a proper data source and keep it on the IT side, but the business doesn't quite want that. How are you managing with that?
Yeah, that's a good question. They're getting what they want, and they are satisfied. I know the situation. So basically, we have a third-party vendor who measures seismic when we are doing blasts, and they send us just a report of cherry-picked values, and the business side is very happy with that. But we need to make the business side to really understand that this data can also be incorporated with other information. So this is a lot of work I do. I talk with partners to try and get them to send us all the information, all the data. We try and integrate with their backends. But we also look at other possibilities. I mean, the only thing that the business really care about is to get the value from that graph. And I know in this particular case, we can do it ourselves as well. We don't need that partner for this. But it's always an ongoing battle between should we get another partner or should we use this? Is it super important right now? But the idea is to have everything. We need ownership of all our information. We can't leave it to a partner. What happens if I know the guy? I mean, he's old. He's probably going to be in pension soon. What happens then? What happens if that company goes bankrupt? So, yeah, that's why I also think that it's good when the business side comes to us and ask for help before acquiring a complete solution from a vendor.
Thanks.
Thank you.
Marcus, how do you want this?
Not thrown at my face like I did at you.
I think the
confirm
time
it's
is
not
up,
great.
actually. We have.
Yes, so please give a round of applause for the team.